Welcome to this technical review of the Drainac 3B Online Freeness Analyzer. Before we talk about the Drainac, let's talk a little bit about how people have done freeness in the past. This is the TAPI 227 manual apparatus. You probably have one in your laboratory, and it's the methodology that has been defined to measure freeness, and it's been around for quite a long time. Freeness measured in Canadian standard freeness, by the way. Number of problems with this methodology. It's sensitive to parameters such as temperature and consistency. It can also be very sensitive to the technique that's utilized to actually execute the test. As a consequence, there are a lot of corrections that have to be applied to this to the numbers derived from the TAPI 227 method. Finally, it's slow. By the time you actually get a number from a sample, the paper's on the truck and out the door, which is useful for documentation purposes, but not really useful for managing your processes. Well, here's our solution. This is the Drainac Online Freeness Analyzer. I'm going to demonstrate a few things to you. For example, that it is the fastest analyzer available in the world today. It is also the lowest cost analyzer, not only from an acquisition point of view, but also from an installation and a maintenance point of view. It is the easiest system to maintain. I believe it's the best value of any any freeness analyzer available in the world today, and I hope to demonstrate that to you as well. Finally, I also hope to demonstrate that you'll have a very speedy return on your investment. This is the Drainac system, as it will often look in a mill. Two components. There is a instrumentation cabinet, which houses all the system pneumatics and electronics. There's also the analysis riser, which is typically mounted on a Stockline, but there are other configurations depending on your application as well. And we'll go through those a little bit later in this presentation. So, how does the system work? Well, before we jump into that, let me just describe it. This is the riser, typically made out of stainless steel with a clear acrylic analysis chamber. We do have some other materials available depending on your process chemistry. The bottom of the system is a riser. This is roughly a 2.5 inch OD stainless steel, typically welded into your system. There is a pressure transmitter, which is mounted on the side of it. There's a ball valve typically, which is not illustrated here, which is between the riser and the screen. In the analysis chamber itself, you have two probes, a higher and a lower probe. This center probe-looking device is actually a screen sprayer and doesn't actually participate in the analysis process. These probes, the length of these probes and the internal diameter of this acrylic plastic tube are adjustable. Now, the way the system works is that we monitor the pressure in your Stockline, and we'll adjust the pressure inside the analysis chamber, either positive or negative relative to the Stockline, depending on whether we want to take or exhaust a sample. If we want to take a sample, we're going to drop the pressure some psi below Stockline. The overpressure in the Stockline will then force stock up into the system. When the stock hits the screen, it'll form a pad, and only filtrate will actually enter into the chamber. We wait until the stock reaches this bottom probe here, at which point we start a stopwatch, and we measure the amount of time it takes your filtrate to get from the bottom up to the top probe. Looking at it a slightly different way, if we were to graph the height of filtrate in the system as a function of time, this is what it would look like. At first, the stock would rise very rapidly because there's nothing to impede it. When it hits the screen and that pad starts to form, the response goes nonlinear. This nonlinearity is a function of a number of different things, mainly consistency, and that's part of the reason why we don't actually start the analysis there. what we have found is that after that pad has formed to some nominal thickness, the behavior linearizes. It's not a perfect line, but it's actually close enough that we can model it that way. And so the drain time measurement is basically the amount of time between this lower probe and the upper probe. And that is the native measurement of the Drainac. Now, as your stocks get faster or slower, the slope of that line will change. Faster stocks will have a steeper slope, and slower stocks will have a flatter slope. And as a consequence, your drain time is going to increase or decrease. And that's basically the relationship between your stock's freeness and the Drainac's drain time measurement. Now, once we have that drain time, we can express it in a variety of different units, CSF, Williams, Shopper-Regley, drain time. We basically go through a calibration and the Drainac can be programmed to output those units directly. There are other presentations which are available to you which describe how that calibration process works. Okay, now that we have the measurement, we basically increase the pressure in the analysis chamber, and the sample is going to be flushed back into the stock line. There is no wasted stock. We don't sewer the samples. There's no piping needed to sewer the samples or anything like that. Just go right back into the stock line. At the same time that that's happening, we also turn on a variety of different flush points. There are 3 flush points, one below the screen, one above the screen, and one at the top. And we turn all those on and basically clean your entire system. And we can complete an analysis in roughly 20 to 30 seconds. Okay, so why is fast sampling good? Well, here is an illustration. Here you have 2 data points, and if you were to base your assessment of your process on these 2 data points, you would conclude that you have a nice, stable process. However, if you have more data points, you can see that things might not be as stable as you think, that things can be rather variable. So in general, more data points is better. All right, click. There we go. Maintenance. All right. 2 categories of maintenance. There is periodic cleaning. You have to trot out to the instrument, clean the screen and the probe tips. How often will depend on your stock. Most of my customers will typically clean their system 1 to 2 times, maybe 3 times a week. The other group of maintenance is annual maintenance. There are some components in the Drainac that are consumables, and they basically need to be replaced on a regular basis for the best performance of the system. Let's take a look at what periodic cleaning looks like. As I said, you clean the screen and the probe tips as needed. There is actually a ball valve, as I mentioned, to isolate the system. When you close the ball valve, it exposes a wing nut, which you can then open up to release the riser, and the riser will basically just swing open and give you access to all the things that need to be cleaned. Here's a picture of what it looks like. The ball valve is right down here. Here's the wing nut. There's the screen, and you can see one of the probe tips, and we provide you with a little bottle brush that you can use to keep all those things clean. Of course, when you've got it open, you want to clean the screen and inspect the gaskets, but that's basically the alpha and omega of cleaning. It will probably take your team longer to walk out to the instrument than it will actually take to clean the instrument. Very straightforward to do. And there is a video on YouTube, by the way, of yours truly performing the cleaning methodology, and I encourage you to look at it. The annual procedures, inspections and cleaning and replacing certain components. Personal experience suggests that it will take roughly 3 hours to complete, and there are additional presentations that we have developed that illustrate how to do this as well. Okay, so what do you need to install a Drainac? Well, obviously you want an accessible location. This makes it easy to maintain. Our experience is that if instruments are not easily maintained, people will find excuses not to maintain them. And a unmaintained Drainac is not a happy Drainac. It is low maintenance, but it is not no maintenance. You will need a couple of feet of headroom so you can swing that riser open. You will need a source of instrument quality dry air at a minimum pressure of 10 psi over your maximum stockline pressure at all times. It must be instrument quality, it must be dry, and it must be at 10 psi above that maximum stockline pressure. If you have any concerns about the quality of your air supply, we have a couple of accessories and options for the Drainac, including a air dryer, also a plant integrity monitor in case your pressures drop to seal the system from damage. If you have a lot of dropouts of your air pressure, that could be problematic for the Drainac, and I would recommend considering those options. You also need a source of filtered water, 80 microns or better. Again, it must be 10 psi over the maximum stockline pressure at all times. And of course, a source of electrical power, 110 volts is standard. You can get a 220 volt version if that would work better for you. Installation locations. Well, we have a variety of different configurations that could accommodate almost any location in your mill. For stock lines, we have horizontal and vertical flowing lines. We recommend that they be upward flowing only because downward flowing lines, you never know if they are full or not, and they need to be full. We can also do inclined lines. We have configurations which are suitable for open vessels, weirs, chests, tanks, and hydropulpers. This is an example of a horizontal installation. Here's an example of a vertical installation. We have a special riser fabricated to go there. Here's an example of a weir where you have basically a tube that drops into the stock to sample it. And this is actually mounted on the side of a hydropulper, so you can manage the freeness of your incoming recycle stock at the hydropulper. This application works great, by the way. Okay, so what are the things that people typically use Drainac for? Well, paper machine function, runnability and stability of the machine, most overtly to avoid freeness-related paper breaks. Freeness monitoring in general, or if you have, if your furnace consists of multiple variable stock sources, you can use the Drainac to utilize less expensive fiber sources over more expensive fiber sources, but still maintain your freeness and strength characteristics. And recycle lines, as I've already pointed out. The holy grail of all of this is controlling your refiners. And so the Drainac is often used as part of a freeness endpoint refiner control strategy, which is just another way of managing how much energy actually the refiner is giving to your stock. Oh, and then pulp blending, where you have multiple sources of fiber. Okay, return on investments. You're going to see improved machine efficiency and stability. You're going to see fewer sheet breaks. Your production improvements are going to manifest themselves as less cost per ton of paper made. You're going to have less lost paper from missed specification tests. Your furnish blending is going to improve. And you can also optimize the energy that your refiners are applying to your stock. The return on investment can literally be measured in hours, but most people pay off their Drainacs in a few weeks to a couple of months. Guess I need to fix my printer. Okay, getting a Drainac. Well, the acquisition program, which is a fancy way of you just buy it. We also have a rental program available, typically meaning that you're committed for 6 months at whatever the current rental payment is, at the end of which you will have an opportunity to either continue to rent, you can return the system, in which case your financial commitment to the company will end, except for damage to the system beyond normal wear and tear. And of course, you can also just convert it to a purchase, in which case you'll get a credit of some portion of your rental payments that you've paid up until this point. Currently, that's 70%, but that could change. It's important to know that if you do use the rental program, that you must explicitly send us a PO to convert it to a purchase. This is not a rent-to-own program. It is a rental program. Now, irrespective of the way that you get the Drainac in the mill, we will include a day of startup services. We will dispatch a Drainac commissioning engineer to your facility who will commission your system, train your personnel in the operation, calibration, and maintenance, and answer any questions that you need. You get that guy for a full day. We do bill you for for any travel and living expenses required to get the technician on site. And of course, if for some reason the startup takes longer than a day, then you'll get billed for labor as well. So, you are not the first person to consider a Drainac. We have a variety of installations in the United States and Canada. There are over 350 Drainacs in this continent. We also have installations in Europe, Asia, and South America. So Drainac is quite distributed. This is a incomplete list of our Drainac customers. Some mills, you will note, for example, IP, have Drainacs at multiple facilities. IP, GP, Rock 10, just for an example. So these are some of our customers. So Freeness measurement is a valuable measurement to have. The manual methodology is problematic. Our system, the TECO Drainac, is the fastest in the world. It is the lowest cost to buy, to install, and to maintain. It's convenient and effective and will bring value to you, the paper maker. And I hope I've been able to demonstrate that there is a rapid return on your investment. So, for more information, please call us. We're Thompson Equipment Company. Our phone number 504-833-6381. Our email address, sales@teco-inc.com, or you can check us out on the web at www.teco-inc.com. Thank you very much for your attention, and we certainly hope to hear from you soon.